In this video, we look at this integral, the integral from 0 to pi over 6 of 1, all divided by the cosine to the 4th power of x minus sine to the 4th power of x, all raised to the power of 4. Before we proceed with the video, we have to look at this integrand again. So this integrand, if from the double angle identity, what is cosine of 2x? Cosine of 2x from the double angle identity is cosine square of x minus sine square of x, right? This is trivial. So if we have cosine to the 4th power of x minus sine to the 4th power of x, this one can be written as cosine square of x minus sine square of x multiplied by cosine square of x plus sine square of x. When we multiply these guys out, we are going to get cosine to the 4th power of x minus sine to the 4th power of x, right? So, but what is this? This is cosine of 2x from the double angle identity. This is cosine of 2x. And what is this? Cosine square of x plus sine square of x from the Pythagorean theorem. This just sums to 1. That is the cosine square of x plus the sine square of x. And this one is equals to the cosine to the 4th power of x minus sine to the 4th power of x. So this one just reduces to cosine of 2x. So this one reduces to just cosine of 2x, right? So I'm just going to replace that with cosine of 2x. So this is the integral from 0 to pi over 6 of 1 all over cosine of 2x by raised to the power of 4 dx. And this is the integral from 0 to pi over 6 of 1 all over cosine to the 4th power of 2x dx. So 1 over cosine is a secant. So 1 over cosine to the 4th power of 2x is the integral from 0 to pi over 6 of secant to the 4th power of 2x dx. So our integral just reduces to the secant to the 4th power of 2x dx. I'm just going to write that here and then we can deal with that. Integral from 0 to pi over 6 of secant to the 4th power of 2x dx. Cool result. And now let's do a u sub. We can let u to be equal to 2x, just simplifying the angle for now. So du is going to be 2 dx. That implies that dx is 1/2 du, or du over 2. Change in limits. When x is 0, that is the lower limit, what is u? U is going to be 2 times 0, which is 0. When x is the upper limit, pi over 6, u is going to be 2 times pi over 6, which is pi over 3. So our limits will change from 0 to pi over 3. And we can now take our integral from the x world into the u world. This is the integral from 0 to pi over 3 now of secant to the 4th power of 2x. 2x is now u, and du. dx is now 1/2 du. So this is 1/2 outside the integral from 0 to pi over 3 of secant to the 4th power of u du. Okay, so I is 1/2. So the integral from 0 to pi over 3 of secant to the 2nd power of u multiplied by secant to the 2nd power of u du. We know that tangent square of u plus 1 is going to be equal to the secant square of u. That is from the Pythagorean identities of trig. So I is going to be 1/2 the integral from 0 to pi over 3 of secant square u. Secant square u is tangent square of u plus 1, which is multiplied by this secant square u du outside here. And now I'm going to split this integral into two different integrals. That is 1/2 the integral from 0 to pi over 3 of tangent square u secant square u du. That is one integral, plus another integral, the integral from 0 to pi over 3 of secant square of u du. I'm just distributing in with this guy, secant square u. So these are the two different integrals, integral 1 and integral 2. This is integral 1, beg your pardon. Now integral 1, let's tackle integral 1 in yellow. So this is going to be 1/2 the integral from 0 to pi over 3 of the tan square of u secant square of u du. I'm going to do a u sub here. Well, a k sub, because we already have u. So let k to be equal to tan of u. Therefore, dk du is secant square of u. That implies that dk is secant square of u du. So in place of secant square du, secant square u du, I'm just going to replace with decay. And now the change in limits. When u is 0, that is the lower limit, k is going to be tan of 0. Tan of 0 is 0. When u is pi over 3, k is going to be tan of pi over 3. Tan of pi over 3 is tan of 60, and tan of 60 is the square root of 3. And now the integral in the k world is I1, 1/2 the integral from 0 to the square root of 3 now of tan square of u. Tan of u is k. So this is k squared, and secant square u du is decay. Cool. So integrating this is 1/2 times 1/3 k to the third from 0 to the square root of 3. This is 1 over 6 k to the third from 0 to the square root of 3, which is 1 over 6 square root of 3 raised to the power of 3 minus 0. So I1 is 1 over 6. Square root of 3 raised to the power of 3 is square root of 3 times square root of 3 times square root of 3, which is 3 square root of 3. And that is going to be 1/2 square root of 3. This is the value of I1. Now let's deal with the I2. The I2, what is really the I2? You can go back up. The I2 is 1/2 the integral from 0 to pi over 3 of secant square u du. 1/2 the integral from 0 to pi over 3 of secant square u du. This is really very easy. The differential of tangent is secant squared, so the integral of secant squared is just the tangent. So this one is just 1/2. Integrating secant square u in the u world is tangent of u. The limits of integration from 0 to pi over 3. So I2 is going to be 1/2. You can just plug in your limits now. Tan of pi over 3 minus tan of 0. Tan of pi over 3 is tan of 60. Tan of 60 is the square root of 3 minus tan of 0 is 0. So this one evaluates to 1/2 square root of 3 as well. Right? This is very easy. So I is the sum of the two, I1 and I2. I1 is 1/2 square root of 3. So I is 1/2 square root of 3 plus I2 is 1/2 square root of 3, which is square root of 3. So this one is the answer to our integral. So if we go to the very top, this one evaluates to the square root of 3. So I think the main work was just in trying to figure out what cosine to the 4th power of x minus sine to the 4th power of x is. Once you are able to identify that it's cosine of 2x, then everything becomes trivial. So that is how I can solve this integral. If you have an easier way of solving this, leave a comment in the comment section and let me know what you think. Anyway, I thank you so much for watching this video. Please subscribe to Calculus Diary for more content, and I will catch you up in the next one. Bye bye.